for inviting me and having me here to the Miami Jug. Just a little bit of background on me. So I many years ago, I founded the New York Java SIG way back when. So I guess the first day that Java was announced in New York, um, I was asked. I was a consultant to Sun Microsystems, and I was asked to do a tutorial on Java. It was like a month or 2 months before that. And I said, that sounds great. What is it? So I said, please talk to James, James Gosling, and find out more about it. And at that time, I was working at AT&T as a consultant, one of my other clients. And I was responsible for maintaining James's code for a windowing system that he wrote called the Network Extensible Window System. So I had talked to James about that and asked him a lot of questions about his code. Why were there so many go-tos in his code? Um, so he explained what Java was, and I said like, well, this is way more than I thought it was. I thought it was just going to be another language. And back then, new languages came up like every month there was a new language. But I said, actually, this is way more than a new language. So I got really excited about this. So I gave a mini tutorial that day that Java came out. So I was the third person that ever gave a Java tutorial. James was the first one. Arthur Van Hoff, who was also a Sun employee, uh, co-founder of Marimba back then. He was number two, and I was the first. It was the third person, the first non-Sun person. So I started the Java user group that day. I was also running the Sun user group in New York at that time. That's how Sun knew me. And we started a special interest group because back then, when you had special interest in a bigger group, you were called a SIG. If you were interested in computers and you wanted to talk about PCs, you had the PC SIG. So we had in the Sun user group, we had the Java SIG, and that's why we have the name SIG, and it's sort of historic, and that's why we're called a SIG. For the past 7, 8 years, we have a bunch of very qualified people to help run the Java group in New York. Certainly, Victor is one of them. We have a bunch of Java champions that run the New York Java SIG. So it's a great community. Um, and I've been involved with machine learning for also a long time, maybe longer than Java. I'm also a musician, and been a musician most of my life. And in my graduate study, so my graduate project in computer science, I was very interested in simulation. And I thought a really cool graduate project was to look at an artist, a musical artist, look at their melodies, like they generate an original song, look at a melody, and then determine a style from that melody. Like look at all the melodies that a certain composer wrote, determine a style, then generate a new song in that style. That's generative AI. And we didn't call it generative AI. As a matter of fact, I don't think you called it AI. So going back way back when. So it's kind of I have to laugh sometimes when I see some things come up with machine learning, some questions and concepts come up. Like goes, yeah, I think we talked about that decades ago. So it's fun to see things come into fruition as we start to see AI go into production from just playing around and honestly we're still playing around with figuring out which direction this thing is going in. But it's nice to see that at least some companies are attempting to put it into production. And with Java, now that we're in this production phase, Python's a great language for playing around with data science. If you're a data scientist, Python's the language to do that. But now we're moving into production, and what language is strong in production? It's Java. That's Java's forte, right? Production. So this is cool. This is really good timing for Java. So another reason why I created this presentation, I noticed that, of course, there's a lot of hype. If you notice, a lot of the hyperbole about generative AI is coming from the big companies that produce services that you need to subscribe to. So you always have to remember when someone talks about something is that who is actually saying that and why are they saying that? So when you listen to OpenAI executives, and we know the number one executive there, when they say something about AI and AGI and ASI and all these super intelligent things, why are they saying that? Okay, they're the number one salesperson for that company. Why is the NVIDIA chairman saying something? Because he's the number one salesperson for that company. So with that in mind, think of that and not fall for the hype that you see a lot of the content that's out there. And unfortunately, because of the internet and the web, the thing that attracts people is hype, right? And companies know that, and they're trying to leverage that to make money. So just be aware of that. A lot of it is hype. A lot of it is interesting and true. Much of it is hype. I also noticed that in talking to developers and talking to senior developers, CTOs, I've talked to business executives, I've talked to partners in law firms, I've talked to medical doctors about generative AI, and I'm really shocked that they really don't understand what it is. I mean, I had a conversation with a CTO, a major CTO, about generative AI, and I was like thinking to myself, this person has no idea what generative AI is. And he's the CTO of this major company. So I wanted to create a deck, and I created a slide deck. And this deck is a subset. It's a subset of this AI for busy Java developers. But what I wanted to do is I want to give you what you should know about AI, of course, the Java slant, so that you understand what this thing is. So it allows you to use it properly. Like a lot of people that I see using it like a search engine. It's not a search engine. It's not a search engine. I want you to understand how this thing works so you can use it more effectively. So with that in mind, we're going to try to do this in like less than an hour. It's a lot of stuff. And again, this is a subset of my bigger presentation, but we'll try to cover some things. And I noticed from the conversation we just had that some of you have already done a lot of work with language models and use it as a tool. I'll try to maybe fill in some of the blanks so that you understand how all this comes together and where's it going. Okay. And we know why we learn this stuff because it's not just like a short-term trend, right? This is in fact a very, very major trend. It's not just about code generation. I know that before we were talking about tools for IDEs. This is code generation is just the tip of the iceberg, right? Chatbots, we're just at the tip of the iceberg. We're almost like in a beta stage of this technology. So we're talking like 10, 20-year trend, right? And as not just IT, not just the IT industry, but it goes beyond the IT industry. It affects world economies. That's how powerful this technology. This is just not an ordinary little technology trend. Okay, so as Victor had pointed out, understanding GenAI, if you want to use it in an IDE, it certainly increases your dev productivity, and we're talking about using it on a daily basis. Developers use this all the time. Okay, let's make sure we understand how to use it properly. Okay, you have to understand the foundations of AI and ML, and I'll riff off of this particular bullet point in a second. Now, for Java developers, the APIs are straightforward. They're very, very simple. I was told many years ago as a young pup, don't say simple or easy, just say straightforward. So the APIs are straightforward. And you really have to know how to use AI because if you don't, your people that know it are going to be hired right over you. So I see this a lot in the Java community, right? And people say like, well, I know there's an AI framework for this, for server side this, or for the developer for my IDE it's just another framework, right? And of course, Java frameworks are all over the place. We have Spring, we have Cloud, Docker, Kubernetes, we have all these frameworks. So the thing about these frameworks and Java frameworks is that Java developers are so used to these things, right? We understand how to make Java better. Java developers know how to make Java better. We know how to make it better. We know how to deploy it, right? We know how to optimize it. That's our thing. So all these on this slide, all that stuff is about how to make Java better. But now we're talking about AI. So if you're developing an e-commerce system, right, and you're a Java developer, and then somebody asks you about the e-commerce application of your Java tool, you might not know the answer to that question. It might be another group. Or if you're building a trading system, you're working for an investment bank, you're building a trading system in Java, and somebody asks you about like about the total return for a fixed income asset, and you're just like, yeah, geez, I don't know that. I'm a Java developer. So in the past, we had other people worry about what the application of the frameworks and the tools and the libraries and the packages. This is different. This is not you. You can't say it's a framework. I'm just going to plug it in, and I have machine learning AI in my program. I'm done. It's completely different. This is a completely different animal. So don't think of it as a Java framework that you're going to use in your, as a something in your toolbox, and you're going to instantly have AI in your application. That's not true. But the APIs are very easy, right? And this is just there's no library here. It's just pure. Well, there's HTTP class in here, so you can copy paste this into a command line and run the Java program. The new Java that you can run this code in a one compile and run a one shot. That's it. That's sending, what is this? This is OpenAI. So OpenAI key. So it's connecting to OpenAI. It's sending a message, tell me a funny joke about programming Java. It's probably going to tell you something stupid about C# and something like that. But there it is. It's very simple, right? And here's another example. This is using, what is this using? This is using LangChain4j, which is a cool library that abstracts. It's an abstraction above all other language models. Pretty cool. Not the fastest thing in the world, but it works. So for prototyping, it's really, really good. It's not bad. One page, right? I connected to, well, of course, you have to have the OpenAI key. Like we all know, you have to register for an API key for any service. I send a message, I get it back. Pretty damn simple, right? Okay, but what's the problem? So the problem is that Java developers, I like to call them shoegazers. So, if you're in a band, if you're in a musical band, you're the drummer, the guitar player, the bass player, keyboard player, you're into your gear, right? And you like your gear and you're into your music and you have a gig coming up and you say like, well, the drummer is a punk metal guy and he knows all about drums, and then the guitarist and she knows about her pedals and what pedals to do this and what amplifier it gives her the best tone. The bass player is worrying about what type of strings. Everybody knows about their gear. Everybody knows about their gear, and there's a gig coming up, and they said, "Wow, we know all about these different types of music, and we know all about our gear. We're going to show up at the gig, and we're going to rock out, and we're going to like be the best band everyone there has ever heard of." And then you get to the gig, and you look up, and you see an audience like that. It's like, oh, so I guess we're not playing punk metal or something else. Like these people want to see something else. They want to see Taylor Swift. So that's like a Java developer. You have to know your audience. You have to know what you're building. And this is why machine learning is different from just using other frameworks, because the other frameworks are tools to help Java, right? To help Java deploy, to help Java debug, to make it structurally sound, right? It's Java for Java. This is different. Okay. So we know generative AI is becoming a tool in the entire software development process, right? And we know that we talked about just before I started about using it for code generation, or questions about code, chatbots. This is just the tip of the iceberg. We're just getting started, right? The transformer architecture, which basically kickstarted the recent AI, this is like 2017, the transformer architecture was invented. We're just seeing the tip of the iceberg, right? And as I said, the APIs I mean, we're Java developers. We know how to learn APIs. This is really, really simple, especially since most of the APIs are REST APIs. So it's very, very straightforward. So the thing is that we have to understand AI foundations, the AI and the machine learning foundations, not just the tools, right? So this is why you have to step away from being a Java developer. And if you there's so many presentations out about the Java tools, Java, here's a library, here's a framework. In my opinion, take a step back before you kind of focus on the Java plumbing, right? And the Java toolbox of goodies. Take a step back. Let's understand the foundations of what we're trying to do, not just the tools. So let's do that. So most of my presentation is not so much about Java. I mean, I'll show you some Java code later. Hopefully, if I have time, I'll fire up IntelliJ. But let's take a step back. Let's talk about, in general, artificial intelligence and where does that come from? Okay. So everything that we know involves patterns, right? If you're a musician and if you have two guitarists and I said we're gonna play a blues in the key of C and it's a 1-4-5. When I said it's a 1-4-5, that other guitarist, presumably it's not somebody beginner, but someone that's been playing for a while, they know, oh, you're gonna do a 1-4-5 in C. What was that pattern? Oh, okay. I know what that pattern is. I could jam with you. If a jazz guitarist knows a 2-5-1, we're gonna do 2-5-1 in the key of A minor. They could play together. If you're a sports team and you know the rules, you know the patterns of that sport. If you're on the offense, you should learn about the patterns of the defense. If you're on a defense, you should learn the patterns of the offense. If you're in investment banking, you're building trading systems, you're looking for patterns, right? You're looking at patterns of how assets behave, whether they're stocks or they're bonds or commodities. Um, I was about to say a joke about crypto, but I won't say it. And there's patterns in business, like patterns of problem solving up there. There's innovation patterns. So there's also in astronomy, there's supernova, how a star starts to pulsate and it becomes unstable, then it explodes and it becomes more stable. That's a pattern. Actually, I studied astrophysics as an undergrad, and I noticed that there was that pattern of instability and then a bit of chaos, and then there was a explosion, and then it was down to a stable state. That happens in business. That happens in IT when we have something like build systems and C++, and the complexity got so crazy, and then all of a sudden we had Java. I said, wait a minute, there's a similar pattern to a supernova. So if you look around at all this stuff, and here I've good old Elvis there. So why was Elvis popular? And why was Kurt Cobain popular in the 90s? Why were the Beatles popular? Well, they all followed a decade of instability. Pattern. What about those bears up in the right-hand corner there? How did they know to find food? How did they know the salmon were right there at that waterfall? They they understood patterns. Everything here on this page, even there's Duke up our Java mascot up top here. When we design Java classes, what are we doing? We're looking for patterns. It's like, whoa, patterns again. We look for patterns and we put them into classes. It's like, wow, there's more patterns. All of these things on this page are involve patterns. Patterns are everywhere. We are pattern creatures. We live in a pattern universe. And what's machine learning? Machine learning is all about patterns. We look for patterns in a data set, and either we're predicting the future or we're generating new things that follow that pattern, right? And we should all know this book, right? Design Patterns back in this is 95. It's obviously still used today. So this book on design patterns, it was written it was based upon a talk by Kent Beck and Ward Cunningham at a OOPSLA conference. What is OOPSLA? Object-Oriented Programming Language and Systems, I think, but a conference, a tech conference. So this book was based on a talk. It was patterned after a talk called Using Pattern Languages for Object-Oriented Programming. So it was patterned. It's a book about patterned on a talk. So that talk was based upon this book. It was patterned after this book in 1977. This book had nothing to do with software. This book was about physical buildings. So, and this book was instrumental in influencing the development of Agile. And Ward Cunningham created the first wiki based upon this book. This book had nothing to do with software. That's pretty cool. So then we had a book on patterns was based upon a talk on a pattern of languages, which was patterned based upon a book on a pattern of language physical buildings. What was this patterned on? This was based upon homes from centuries ago. So what my point is here, patterns have been with us for a long, long time. And now that we know we're that book of the Gang of Four book, so next time you build some Java code that uses a decorator pattern, know that it originally came from this stuff, which is pretty cool. So it's not something new, right? It's not something new. Those patterns in that Gang of Four book come from this. Now, what else do we know about patterns? Well, we know regular expressions, right? We're all professional developers, so we use regular expressions all the time, constantly. Very powerful. It's like, when we use them in a program, whether it's Java or C or whatever, it's a language inside of a language. Now, regular expressions are about patterns. It's interesting.